All right. It's going. All right. Hello, hello. Today we'll be doing Path Sum 3. Um, yeah, I guess we'll just read and get into the question, I guess. Given the root of a binary tree and an integer target sum, return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at the root or a leaf, but it must go downwards, i.e., traveling only from parent nodes to child nodes. Um, yeah. Uh, Not sure if there's much for me to explain. Um, you just gotta go down the paths, right, and then just see if you have anything that would add up to the sum that you want. If not, then sucks. We move on with life. Um, yeah. All right. So once again, we're still using depth first search. So we will be writing the actual like technically the actual solution last. We'll be writing the helper first. So with that being said, let's get into it. We're gonna define a path sum helper. We need to pass in self because we're within a class. We're gonna pass in node, which is an optional tree node. We're just gonna call it target for the int, and we're going to have a current path, which is a list of int. Oh, double register in keyboard. Great. And here we're going to be returning an integer because we just want the number of paths, right? So from here, if not node, basically, um, if the node that we're currently looking at is null or none, we're just gonna return 0 because there's no paths from there to for literally any um, yeah, there's just no paths in order to get to any value regardless because it's none, right? So now that we know we do have a node, we want current path dot append node dot value because it's part of our path now, and we want to calculate our we want to calculate our what do you want to call it? We want to calculate the sums of like the path so far, right? We're going to have a path sum and a path count. Um, they're going to be both starting off at 0. The reason why we have a path sum, it's not to be confused with this. Let's just do this instead, just so we don't get, like, I guess, um, confused with this. Even though in order to call this, it's a whole method call. You have to do self dot whatever in front of it. I guess just to eliminate confusion. So basically, since we need to have a path count because it's possible as we go up, like it's possible that anywhere there could be the potential sum, and then we want to be able to calculate all of them, right? Because in this example, I guess it's not really there, but let's just say we have a -1 here, right? So we would technically have um you know two paths. It could just be from here to here and all the way from here to -1. Wait, let me see if you can see the mouse. Yeah, you can. So basically, if there's a -1 to the right of, or I guess it could be to the left of this one, that's another path. So we want to be able to account for all of those. So we need to have path count and whatnot. And it could be in between too, right? Like let's just say there's a -3, 11 here. It could be, let's just say, another -3 and another 11 just to make things easier for my mind. Um, that's one path, and this would be another path. So we need to be able to account for every situation possible. So we need to have these variables. And so in order to calculate our path sum so far, we're going to do um, we're going to be using a for loop. Um, but instead of going forward from like 10, 5, 2, 1, we're going to go backward. The reason why we want to go backward is because essentially you can isolate like different paths, whereas if you go from top down, like it might not be as accurate. And also because since we're doing depth first search, um like realistically only the back nodes will be changing or like adding stuff on, so you want to do it backward. So you'll do current path, whoops, -1. Okay, remove the parentheses, and you want to stop before -1, -1, and you want to go backwards. So the iterator will be set at -1 in order to go backwards. Our paths sum is plus equals to current path I. If path sum is equal to target, then we're going to path count plus equals 1. Yeah, and that's it for our for loop. We're just gonna iterate backward, and then we're going to be able to calculate all of the paths that we have, and then we're going to do path count is plus equal to self dot path sum helper node dot left target and current path, and then plus self dot path sum helper node dot right target and current path as well, because we want to account for every path possible, right? So we got to go down the left and the right, and then before we recurse back up from this call, so let's just say we're here, right? And like we've calculated the path so far for like this number target sum 8. We don't have a path yet. We want to go down the left and go down the right, and that's what we're doing here. And before we go up back to 10 and then go to the right, because on the 10 call we would have went down this path on the left, and we need to go back up and call the right. So before we go back up, we need to remove the 5 from the list, current path list, because it's not part of the path anymore once we go back up. So we want to remove that, and then we'll return path count, because that's the count that we actually have calculated so far from 10 to 5. If we're on this call here to start up here, then we calculated all the paths down here for here, and then we want to remove the 5 and then add the -3 in the next call when we go down this way. So but then we've been passing the count around, and then for the 10 call, this will be 2 for here, and after it finishes the right, it'll be 1, and then it'll be path count, which starts at 0, and then 10 for the 10 here, we don't have any 8s, so then path count would have stayed at 0 here, and then 0 plus, what was it, 2, and then plus 1, and then the pop for the 10 node doesn't really matter, but then it just removes it, and then we'll return 3, which is how we'll get to the solution here when we do return self dot path sum helper root target sum. The target is target sum, and we're going to pass in an empty list for like the path forward. Yeah, with that being said, looks about right. We'll submit it, and it's good. Yeah, that is it. Thank you for watching.